The question is, if z is equal to f of xy, means z is function of x and y, and x equal to r cos hyperbolic theta, y equal to r sin hyperbolic theta, then show that x minus y times of del z del x minus del z del y, which is equal to r del z del r minus del z del theta. So we will let us try to solve that. We have given that z is equal to f of xy, means z is function of x and y. Let us give it equation number 1. Similarly, x equal to r cosine hyperbolic theta. Let us give it equation number 2. Similarly, y is equal to r sine hyperbolic theta. So let us give it equation number 3. Now, then we have to prove that x minus y times of del z del x minus del z del y, which is equal to r del z del r minus del z del theta. So now if we see the last expression here in the left hand side, x and z is dependent variable in left hand side, and also in the right hand side z is only the dependent variable. But in the left hand side, if we see x and y, they are independent variable, but in the right hand side r and theta are independent variable. So this is again the problem based on the change of independent variable. So if you want to change the independent variable, we use the composite function. So clearly here z is function of x and y, and x and y are functions of r and theta. So z is composite function of r and theta. So therefore, we use the formula. We want to calculate what is the value of del z del r. So del z del r is del z del x into del x del r plus del z del y into del y del r. And similarly, del z del theta equal to del z del x into del x del theta plus del z del y into del y del theta. Now, so using the composite function, we are able to find out what is the value of partial derivative of z with respect to r and theta. Now, since x and y are functions of r and theta, so we are able to calculate what is del x del r, what is del y del r, what is del x del theta, and what is del y del theta by using these two uh, values of x and y, which are the functions of r and theta. So differentiating 2 and 3 partially with respect to r and theta, not x, it is what? It is r and theta. We have, what is the value of x is r cos hyperbolic theta, y is r sin hyperbolic theta. So del x del r, which is equal to cosine theta, cosine hyperbolic theta, and del x del theta. Why? Because here cosine hyperbolic theta is constant with respect to r. So derivative of r is 1. So we have only cosine hyperbolic theta. Similarly, del x del theta. So we know that cosine hyperbolic derivative of cosine hyperbolic theta is only sine hyperbolic theta. No negative value comes over here, right? So similarly, del y del r, derivative of r is 1. We have only sine hyperbolic theta. And del y del theta, again the derivative of sine hyperbolic theta is cosine hyperbolic theta. So, and we have to multiply by r. So these are the values of del x del r, del x del theta, del y del r, and del y del theta. Putting above values in equation number 4 and 5, we have del z del r equal to del z del x. What is the value of del x del theta del r? It is cosine hyperbolic theta. Plus del z del y and del y del r. What is del y del r? Is nothing but sine hyperbolic theta. Similarly, del z del theta, so del z del x and del x del theta. What is del x del theta? It is r sine hyperbolic theta plus del z del y into del y del theta. So del y del theta is nothing but r cos hyperbolic theta. Now, according to the question, we have to multiplying question number 6 by r and question number 7 and subtracting it from 7. We have r del z del r minus del z del theta. This is the left hand side. What about the right hand side? So we have to multiply these by r. So r del z del x into cosine hyperbolic theta plus r del z del y into sine hyperbolic theta. This is what it is, the first part. Now the second part is del z del x. Del z del x we have to subtract it, so there should be minus sign. Del z del x into r sine hyperbolic theta minus del z del y r cos hyperbolic theta. Now del z del x and del z del x. Let us take outside. So what is remaining over here? R cosine hyperbolic theta minus r sine hyperbolic theta. R cosine hyperbolic theta minus r sine hyperbolic theta, and del z del x we have taken outside. In the remaining part, if you want to take del z del y common from the second and fourth term, what is remaining over here? R sine hyperbolic theta, and here minus r cosine hyperbolic theta. These are remainings. But from this, just look here, x, what is the value of x? It is r cosine hyperbolic theta. So we can replace this by x. Similarly, r sine hyperbolic theta is nothing but y. So x minus y. And now here it is just opposite, y minus x. So if we can write down, this can be written as x minus y del z del x plus y minus x del z del y. If we take minus sign from this step, we can write down x minus y del z del x, and if we take minus sign outside, y minus x will become x minus y del z del y. So now if we take x minus y common, so we have del z del x remaining in the first part and del z del y is remaining in the second part. So x minus y times of del z del x minus del y del z del y. So therefore x minus y into times of partial derivative of z with respect to x minus partial derivative of z with respect to y, which is equal to r del z del r minus del z del theta. This is the desired result, hence proved. Thank you.